Alright, we will start. So we have already discussed about balancing in the previous lecture. There are two types of forces, static forces and dynamic forces. Is everybody able to hear me clearly? Gaurav?
Yes, sir.
No audio disturbance, right?
No.
Okay. Alright, so there are two types of forces, static and dynamic forces, and also you can say that uh, we have defined unbalanced forces are caused due to imperfect machining, inaccurate. So these are some of the examples: inaccurate pitch of the turbines, non-homogeneous material, etc., etc. Okay, the balancing is defined as process of eliminating or correcting either partially or completely the effects of resultant inertia forces and couple acting on the machine part. All right, or component. So this is what is called as balancing, and there are two types of balancing which we have discussed: static balancing and dynamic balance. Right. So in static balancing, we balance summation of all the dynamic forces should be zero, and here dynamic forces should inertia forces should be zero, and inertia couples also should be zero. There are two methods: analytical and graphical. We are going to solve the problems by graphical approach. All right. So let's go to the first problem. So I will just read the first problem. You should have the problem with you. The question sheet is sent to you in your assignment. You can download it from there. Alright. So we are going to start with rotating unbalanced problems. So I'll read the question. A shaft carries four masses in parallel planes A, B, C, and D in this order along its length. Okay. The masses of at B and C are 18 kg. So masses at B and C are given as 18 kgs and 12.5 kgs respectively, and each has an eccentricity of 60 millimeters. Masses at A and D have eccentricity of 80 millimeters. Okay. Angle between the masses at B and C is 100 degree, and that between B and A is 190 degree, both being measured in the same direction. Right. Axial distance between the planes A and B is 100 mm, and between B and C is 200 mm. Alright, so A and B and C is given. If the shaft is is in complete dynamic balance, determine magnitude of masses at A and D, distances between plane A and D, and angular position of mass D. Alright, so you have to find out the value of mass A and D, and distance between plane A and D, and angular position of mass D. Alright, so this is the entire problem. So let's first summarize the data. Okay, what is the given data? So mass of the MD is equal to 18 kgs. Mass of C is equal to 12.5 kgs. Eccentricity of B, that is radius of B, so it is called as RB and RC, that is equal, that is 60 mm. So that is equal to 0.06 meters. RA is equal to RD is equal to 80, that is equal to 0.08 meters. So if you are doing this or writing all this data on a separate page or a sheet, make sure that so you have to send a scan copy of this data also. All right. The diagram part you can either do separately on the sheet, or you can write the data on the drawing sheet itself. Fine. Angle BOC is 100 degree. Angle BOA is 190 degree. All right. So you have to find MA, MD, and X, that is equal to distance between A and B. Distance between the planes of rotation of A and B. All right. This is just a summary of the right, what I have just discussed. Now let's start with the solution. So first part of the solution is to be done is plot the position of planes for A, B, C and D. Alright, so let's plot that. Alright. So position of the planes. First is A. So this need not be to the scale, because it should be logically in the right sequence. So I'm just roughly plotting it to the scale. So this is A, this is B, this is C, and this is D. Right? And distance between A and B, this is given as 100 mm, and distance between B and C,
Sir,
yes,
sir, the lag between your writing and the view is actually quite large.
too much.
15,
Okay,
15 to 20
let me
seconds.
just
Yes, sir.
end it, and I will again reconnect it. How about now? Let me just start writing.
Sir, we aren't able to see the screen now.
Just a minute. Screen will appear in a minute. Are you able to see the screen now?
Yes, sir.
Yes.
Let me just close the screen. Hold on a minute. All right. How about now? Let me just write. Is there still a lag?
Yes, sir, there is a lag.
How about now?
Sir, you write something.
Just a minute. So this is distance x.
Okay, it's okay, sir, now.
Okay. All right. All right. So this is the position of the planes of rotation of masses A, B, C, and D. All right. So they will be rotating in this plane, which is marked by this vertical line. Okay. Now next thing is to plot the angular position of the mass. So that is also given. So I am taking B as a reference because all the angles are mentioned with respect to B, right? And angle B, so let this be point O. So angle DOC is 100 degrees. So BOC is 100 degrees. So draw it. So this is your C. This is B. And this is 100 degrees. And BOA, so BOC is 100 degrees and BOA is 190 degrees. Alright, so 190 degrees means slightly more than 180 degrees.
Sir, it has freeze. Hello, sir.
Yes, I will just disconnect and connect it again. How about now? Alright, so this is
Yes,
BOA.
yes. It's visible now.
Is it in sync or is there a lag? BOA is 190 degrees.
So write something
Pardon?
so that we can. No, I said write something so we
I have
can
already
see if there
written.
is lag.
Sir, it's fine, sir.
Okay. Alright, so these are the positions of the plane and these are the
Sir,
angular. Yes,
sir, do we have to draw this?
yes. On
Okay,
your
sir. So
drawings.
so where do we exactly draw it on the page? Like
See, if your this is
on
your
the side
sheet.
or
On the
yes.
side, somewhere on the side, you can draw it. If this is your drawing sheet, you can draw it somewhere over here. All right. These distances are not to scale. That is not required. This should be in logical order. All right. So it should
Sir,
be yes.
sir, I'm writing this rough part on. I'm writing it in the book, sir. Is that fine? If I draw it over there and the
These
final things I'll
angular
draw them.
positions, you draw it on the these positions of the plane and angular position you draw it on the drawing sheet. That you don't draw in your book. All right. And this is just a logical sequence of the arrangement of masses linearly and in angular position. Is everybody on the same page as I am doing? If you are not following anything, please ask.
So could you please explain it once again? How did we get the angular positions?
Angular position C BOC angle BOC is given in the data. Okay, so that is 100 degrees. All right, and angle BOA is given as 190 degrees. All right, so all the both the angles are mentioned with respect to B. So I am taking B as a reference and I have constructed OB horizontal. All right, and then with respect to B I have constructed mass C taking this angle as 100 degrees, that is BOC. All right, BO and C. And similarly for A, angle BOA is 190 degrees. That's all.
Okay, so thank you.
In angular position diagram, we have to take it up to the scale.
No, this is not required to up to the scale, but draw it logically in you know it should be logical. For example, it is given that radius of B and radius of C is equal, that is 60 mm, right? So that is 0.06 meters. So it is not required to draw it to the scale, but they should appear more or less equal. All right, and R radius of A is and radius of D is 980 mm. So it should appear more than OB and OC. So draw it logically correct. Don't draw OA shorter than OB and OC, so that doesn't look good.
Okay.
Alright, everybody is done with these two diagrams. Can I go to the next one? Alright, can I go to the next slide?
Yes, yes,
Yes.
yes.
Yes, sir.
Okay. So now prepare this table. Alright. So this table first is plane, second is mass, then third is eccentricity, fourth is the centrifugal force. Now centrifugal force Fc is equal to m omega square r. Alright. But omega is common, right? Omega is constant because all the masses are mounted on the same shaft and they are rigidly fixed. So instead of writing m omega square r, we divide this term by omega square. So it is centrifugal force divided by omega square. So we just write the value m into r. Okay. Then distance from plane A and centrifugal couple, that is m into r into L. Alright. So one by one I will just fill the data.
Sir, this
Now
is in drawing paper or
on
notebook?
your drawing sheet, Alright. So A is the reference plane, then you have B, C and D. These are the four planes, and A is taken as the reference plane. Alright, and you have mass of A is unknown, mass of B is 18 kgs.
Sir, why we divide by omega, sir? Can you please repeat?
What divide this one? See,
Yes,
instead
yes.
of multiplying this term by omega square again and again, so this quantity will become very large, right? So just to simplify our calculations, instead of doing m omega square r, we are just going to use the value m into r, because omega square is constant for all the masses. Angular velocity is constant for all the masses.
Okay, okay, sir.
Alright. Okay, so mass of A is unknown, mass of B is 18 kgs, mass of C is 12.5 kgs, and mass of D is md, that is also unknown. Alright. Now eccentricity, that is radius of rotation. So Ra is now I converted into meter, 0.08 meters. See, units are already mentioned in the top of the table, so I am not writing the units when I am entering the values. Okay. Radius of B is 0.06, radius of C is also 0.06, radius of D is 0.08. Alright. Now multiply m into r. So this becomes 0.08 into MA, and this becomes 1.08, this becomes 0.75, and this becomes 0.08 into MB. Alright. Now distance from plane A. Now since A is taken as a reference plane, so for A the distance will be 0, and B is 0.1, C is 0.3, and this is unknown. This is what you have to find out. Everybody is clear how we got these distances? This is from this distances. So between A and B this is 0.1, between A and C this is 100 plus 200 divided by 1000, so that it becomes 0.3, and this is unknown, so it is written as x. Alright, so 0.1, 0.3 and x. Right. Now last column is couple, so this is m into r into this column, that is L. Alright, so first one, since it is L is 0, so it becomes 0. This is 0.108, and this is 0.225, and the last one is 0.08 mdx. Alright, so that completes our table. Alright. So this is just the same table I have written, and I have just placed the angular position of the masses. These are the angular position. All right. So next we are going to construct the couple polygon. All right. So these are the values of couple. The last column. So this is CA. This is CB. This is CC, and this is CD. All right. So can I start with the couple polygon? All of you are done up till this?
No, sir. No,
You
sir.
don't have to redraw
No,
this.
sir.
No,
I have drawn it for your reference. You don't have to redraw this angular position again. Huh?
So we are making the table.
Table. Huh? Okay.
Sir, for the first sum, please go a little slow.
Yes, yes. So this is slow enough, right?
So can you open the previous slide?
This one.
Yes, sir.
This one and this one is same. The one on the top and this thing, it is the same thing. All right. Can I open this one, or do you want a big one?
Sir,
Yes.
sir, why are there 4 planes and only 3 masses? I didn't follow that part.
No, no, no. There are not 3 masses. See, there are 4 planes and 4 masses. See, MA, MB. All right, let me just write. MA, this is MB, this is MC, and this is MD. So there are 4 masses. All right, and then there are 4 radius of rotation for each of them. That is the distance from the, that is this distance. This is RA, this is RB, this is RC, and this is RD. Okay. So these values are entered over here. Okay. Then centrifugal force is m omega square r, but we are dividing this column by omega square. So it is just this third column into fourth column. So it is 3 into, sorry, the second column into third column. Second into third, that is equal to the fourth column. Alright. So these two values are multiplied. Now I have taken A as a reference plane. Alright. So A is the reference plane now. Alright. Now taking A as a reference plane, I am entering the distance of masses B, C, and D with reference to A, the reference plane. So distance of reference plane A is with itself is going to be 0. Distance of reference plane B is this distance 100, that is 0.1. Distance of reference plane C from A is 100 plus 200, that is total is, this distance is 300 divided by 1000, converting into meter. So that is equal to 0.3. Alright. And distance of D from A, that is not known. So we have marked it as x. So I have written it as x.
So in the angular position diagram, why have we not shown mass D?
Because we don't know the angular position of mass D.
Okay,
So that
okay,
we have
sir.
to find out.
Okay.
Alright. Is it clear now?
Yes, sir.
Okay. And the last column is just the couple, that is column 6 is 4 into 5. Column 4 into 5. That gives you column 6. Alright, everybody has completed the table. Can you just raise your hand in the chat box if you are still doing the table? Just raise your hand in the chat box if you are still doing the table. Just few students are there. 11 students have raised their hand. That's all. Out of 68. Alright, I'll wait for a couple of minutes. If you are done with the table, just lower your hand. Okay, most of you are done. Alright, so now let's start with the couple polygon. Alright, so we are now going to construct the couple polygon. Alright, so just like you construct a force polygon, you are going to construct a couple polygon. That you must have done it in your engineering mechanics experiment during the first year. Alright, so the various values of couple are shown in this table. So couple CA is 0, CB is 0.108, CC is 0.225, and this is CD. This is unknown. Alright, so CA is unknown. So we are going to start with CB. Alright, so take one reference point and plot the couple CB. The vector couple should be the direction of the vector of the couple. Direction of the vector of couple CB should be same as the direction of the mass with reference to O. Alright. So if I take O as a reference, right? If I take O as a reference, OB is going radially outward on the right hand side. So CB should also go in the same direction. So I am going to draw a vector from O horizontal, and this is going to be my point B dash. The points on couple polygon will be denoted by a dash, force polygon without the dash. So that is the convention which you are going to follow. Okay. So this is your
Sir, is this a rough
no,
diagram or
no, to
up
the
to
scale.
scale?
I will
Okay,
say
sir.
tell you how to draw it to the scale. So this is your vector CB. Now this you have to draw to a certain scale. So choose any suitable scale. Alright. So CB is actually 0.108. So convert it into some suitable scale. Say this is as what to say 3 centimeter or 4 centimeter, something like that. Alright. And accordingly, something like that. It depends upon you. Alright. And then accordingly, the other values are going to be adjusted. So this is I have taken as 4 centimeter. 1, 1, 2, 3, and 4 approximately. Alright, so this is 0.108 to the scale CB. Okay, and vector CB is parallel to OB. Okay, OB in this angular position diagram. All right. So once you have constructed OB, now construct the next vector, that is CC, and so vector, now you are going to construct vector CC, that is couple of C, and it is parallel to OC. All right. So I am going to construct the second vector. And direction of the arrow should be along the direction of the mass OC. Right, so this is your point C dash.
Sir, how CB is parallel to OB?
Not OB, OC. Just read what I have written.
First statement, sir, vector CB.
CB is parallel to OB. Because we are drawing the couple for OB, for mass B.
Okay. I get.
Similarly, B dash, C dash, or vector C, I should write this as C, that is equal to 0.225. So again, C
Sir,
is, yes.
sir, for accuracy, the angular position of masses diagram should be not rough, should be with
No,
scale.
see, I said the
Angle.
angles should be accurate.
Okay.
The distances, this 60, 60 and 80, that need not be accurate. The angle should be exact angle. That is what I said.
Okay.
Done up till this. So now again you
No,
have to
sir.
convert CC is equal to 0.225. So convert it into suitable scale. So if I taken 0.10, it as 4 centimeter. So how much will be 0.225? So you have to find the proportion. Right. So this angle should be 100 degrees. And length will be slightly more than 8 centimeters. Can you raise your hand in the chat box if you are still doing it? All right. Once you are done, please lower your hand so that I will be able to know. If you are done, please lower your hand. Alright, most of you have completed. Now only thing remaining is join C dash with O dash by dotted line. And this dotted line, this is your vector 0.08 mdx. That is the length of this vector. Alright, done up till this. Those who have finished with the couple polygon,
No, sir.
those who are still doing, please raise your hand. Let me see how many. Those who are not finished with the couple polygon, please raise your hand. Those who are done with the couple polygon, please lower your hand. Huh? If you are done with the couple polygon, just lower your hand. Alright, so most of you are done. So now we have completed the couple polygon. Now using this, you can find the angular position of mass D. So angular position of mass D will be parallel to this vector CD. So this is your vector CD or C dash O dash. So draw a line from O parallel to C dash O dash. So use your roller scale, keep your roller parallel to this vector O, or if you have a set square, you can use a set square. If you don't have anything, just measure this angle and then construct a line that is will be parallel to O dash C dash. I'm just going to construct the line parallel to O dash C dash. Alright, so this is my mass D. This is M D. Alright, so now I have got the angular position of mass D. This should be 80. Approximately it should be 80 in proportion to 80. This is 6. RC and RB is 60. RA and RD is 80.
Sir, how you got that 80 distance?
Because it is given, na? Radius of radius of A and D is 80.
Okay, okay.
It is given in the data. Alright, finished up till this. So I'm just going to replot this angular position on the next page. Okay, so that's all I have written. If you are still not completed with the angular position, then raise your hand. So very few students. Any questions till now? Before I go to the last step now. Alright. I hope there are no questions. Nobody is asking any questions. So I hope everything is clear up till now. So now we are going to do the last step, that is plotting the force polygon. Alright. So from this angular position of the masses, now we are going to plot the force polygon. Again, we are going to use the same method, and value of these forces are from this centrifugal force column. Okay. So this is FA, this is FB, this is FC, and this is FD. Alright, so that is the scaled value of centrifugal forces. Actual value will be multiplied by omega square R, omega square. So that will give the actual value. But for constructing the the polygon, these values are sufficient. Okay. So FA and FD are not known. So we have to start with FB. Alright. So FB is, I will write a value of FB. FB is 1.08 and FC is 0.75. Alright. So FB is 1.08 and FC is 0.75. Alright. Now draw a vector parallel to OB in the direction of OB. So choose a suitable point O anywhere on your sheet and draw a vector OB to a suitable scale. Alright. So this is O, this is point B. Alright. So OB is equal to 1.08 and choose a scale. So force vector, force FB, vector is OB, scales, choose some suitable scale, say OB is equal to 5 centimeters, something like that. It's up to you, whatever scale is convenient to you, you choose that.
So your screen is not visible properly.
Okay, just a minute. How about now?
Yes, sir.
Okay.
Sir, the scale is 5 centimeter, no?
5 centimeter, yes, yes. Just a minute.
Okay.
5 centimeter. Now you don't have to take the same scale, just take any convenient scale. So draw OB equal to 5 centimeter. Now FC, again value of, so this is given, this is 1.08, FC is 0.75. So draw a vector BC parallel to OC. BC This BC and it is parallel to OC. Alright. BC OB is parallel to OB from the angular position, and BC is parallel to OC. Again, you have to convert it into suitable scale. It will come slightly less than 5 centimeters. Right. And draw the arrows since they are all vectors. Are you finished up till this one? How many are still doing the second step of the fourth polygon? Please raise your hand. That is BC. Those are not finished till BC. So BC will be, this will be 110 degrees. Sorry, 100 degrees, not 110 degrees, 100 degrees. Alright, if you are done with the BC part, please lower your hand. Alright, so most of you have finished. Now you have OB and BC. Now you have to locate the point D. Alright. So to locate the point D, next what we are going to do, we are going to draw. So OB and OC is done. So next you have to draw OA, right? So that you have to draw from C. Alright. So from C, draw a line parallel to OA. Alright, so from C, draw line parallel to OA, and from O, draw a line parallel to OD. Right. So these two lines will intersect. Yes.
Sir, can you repeat the step from C? Like
From
which
C,
path? Yes,
from
sir.
C, draw a line parallel to OA, and from O, draw a line parallel to OD. Right. So both these lines will intersect at a point, that is a point D. Alright. So this is FA, that is equal to 0.08 MA, and this is FD, that is equal to 0.08 MD. So from O, draw a line parallel to OD. These are the vectors. Alright, those who are still doing this part, please raise your hand so that I get a good judgment. So the last step is remaining.
Sir, the lines for the CD and OD in the force polygon, are they dotted or solid?
No, no, solid. I have just drawn it dotted for this part. Okay. You have to draw it like this. Alright, so this is, I just reconstructed the polygon on this next page. If you have any questions, please ask.
So what is the angle between BOD? Means the angle BOD.
BOD that you have to measure, that is not known. This angle, na, BOD, that is not a given angle. Na? So that angular position you have to determine. Alright, all of you have, those are finished up till this force polygon.
Sir, this must be where D is written. There should be A, right? Because
No,
we
no,
considered angle of A for
no.
means
No.
in
This
the
is
fourth
OB,
polygon.
this is BC, this is CD, and this is DO. Vectors,
Sir,
this represent.
considering the angle we considered of A means
No, we have to
190 degree.
consider the vectors which are parallel to this angular position of mass. Alright. See, this vector is parallel to D. So this is F D. This vector is parallel to vector A. So this is F A. Angular position you don't get it from here. This is derived from the angular position. Angular position you read it directly from here, which you have got from the couple polygon. See, angular position you have got it from here. See, theta D is 251 degrees. That is this total angle. Just measure theta D. It should be around 250 degrees. So that you have got from here. You are not going to derive the angular positions from this polygon. That is from this angular position. You have got it. So this theta D is 251 degrees. Alright, all of you are done with this polygon. Okay, so most of you are done. Alright. So now let's do some calculations. So now we are going to find out all these masses. So now convert these vectors, measure these vectors and convert this into actual value. So 0.08 MA, so that is this vector CD, find out the value. And I have calculated it and I am getting it is 0.77 kg meter. So you have to use the same scale which you have used to draw it. Like for example, you have used scale 5 centimeter is equal to 1.08. Okay, so measure DC. So DC is measured and that is okay, not here. DC is whatever x centimeter. So how much is that in kg meter? Similarly measured 0.08 MA, that is vector DO, and I have got it as 0.65.
That is 0.08 MD, na?
MD, correct. MD. That is equal to DO, that is 0.065 kg meter. And find out the values of MA and MD. So MA I am getting it 9.625 kgs and MD is equal to 8.125 kgs. So please raise your hand in the chat box if you are getting values which are close to these values, so that I know how many of you have got it right. Values are 9.625 kgs and 8.125 kgs. Alright, so we are almost out of time. So let me just complete. Now, one more thing is remaining, which is that you have to find the distance of D from A, right? So, if you see your couple polygon, CD is 0.08 mdx. So, measure this vector. Alright. So, from couple polygon, so from couple polygon 0.08 mdx, I get it as, after converting it back in kg meter square, I get it as 0.235 kg meter square. Now in this md is known, md is 8.125. So substitute md as 8.125 and find out x, and that comes out to be 361.5 millimeters. All right. So you have your A, B, C and D, and distance of D we have marked it as x, and this x comes out to be x comes out to be 361.5 mm. Alright, those who are getting values close to these values, please raise your hand. Take the attendance. Those students who are
Sir, I'm
getting
getting quite a different value. So, is that right or wrong?
what values you are getting?
Sir, I got the value for mass of A 11.07 kg and
Mass
mass
of
of
A
D
11.0 and mass of D as
5.94.
no, you have not constructed the polygons accurately.
Sir, can you please repeat this 0.235 kg meter square step?
Okay, just a minute. See, go to the couple polygon. Alright, so here we have this CD as 0.8 mdx, right? So measure this vector and convert it into scale. Alright, so when I do that, when I convert it into kg meter square, I get 0.08 mdx is equal to 0.235 kg meter square. Alright, now in this md is known, that is from our force polygon we have got it as 8.125 kg. So substitute md as 8.125 kgs and that will give you the value of x, that is the distance of D from A. Alright.
Sir, for X, how much, like, if it's coming 7, 8 mm plus minus, is it all
That is
right?
fine.
Yes, sir. Thank you.
Plus or minus 5 to 10 mm is okay.
So I am getting 30 mm less than your value.
Then there is a lot of error in your calculation. You have to just check the calculations again, the diagrams.
Okay.
Yes, anybody who's getting any other different
How much
weird.
deviation is allowed?
5 to 10% deviation is allowed. It depends upon the person who is doing the checking also.
Sir, I got 355.6
That is
mm.
that's distance, na x, na.
Yes, sir.
355 is okay.
351, sir.
Sir.
350 to 370 will be acceptable.
Sir, I got
Beyond that,
344.
I told the range, so no need to individually announce the range. 350 to 370 is okay. Anything beyond that, then there is something wrong.
Sir, should we have to upload this now
Yes,
or?
yes. You have to. If you have got the values as per my calculations, if your calculations are coming close to that, you can upload the values. Or if you are not sure of your calculations, and if your drawing is, since you are doing it for the first time, it is not very neat, you can just redo it and then upload it later in the day. Okay, you don't have to upload it.
Sir, one pic will be okay because on one sheet it is
Yes,
there.
yes. One sheet it will be okay. As long as it is everything is clearly readable to me.
Sir, we have to upload a PDF or directly we can upload an image?
You can upload image also. No, I don't know what is seen in the screen. Upload the, what do you say, the image. Let's see. If I'm not able to read it, then I will ask you to change. Because anyway, this is just the first problem. Like that, you have to solve 4 to 5 problems like this. Alright, so if nothing else is there, we'll stop for today. Any other questions?
No.